Hey there, class. It's just me, Mr. Wee. I just kind of want to go over some content that we were supposed to go over in class on week 1 of month 1, but we didn't have time to. So this is going to be 1.2 functions and graphs. Okay. And before we go on to the main topic, let's do some review over functions. So let's give a function x squared minus 3. That's some sort of equation that you put x into. So what goes in here is your input value. So our input value happens to be an x variable. X is in this position, x squared minus 3. So whatever our input is, it's going to be squared, and then you subtract 3 from it. Not a bad idea. Nothing crazy. And then you'll see this too. Y is equal to x squared minus 3. Okay, and that's just saying your output value is y. So what does this look like? You have x as an input value. We input the variable x. Then we put it through this machine or this sort of equation, f of x, or just f. Okay, let's just say f in this case. Just f, the letter f. Put it through f, and then you get spit out a new value. The new value is y. So y is equal to whatever the value is after you put in x through f. So it's literally the f of x. So f of x is equal to x squared minus 3 is synonymous with the output value that you get after that, which is just y is equal to, well, that's whatever the value was when you put in x squared minus 3. Okay, let's do that again for g of x. And let's say g of x, let's say, is another mechanism or some kind of equation that you can put x through. Okay, again, whatever is in notation after the g of, like into parentheses of x, or into the parentheses, that's again going to be your input value. And you're like, well, isn't your input always x? We don't know. I'll show you. So let's say that whatever gets spit out is going to be z. So x plus 2. Again, notice that the input value when I put in here is now in this position. It's in a position where it's being added to 2, and then you take the square root of that whatever that value is. And then what the detail, the diagram is going to look like here is you put x as an input, whatever you choose as an input, you put it through g, this mechanism of g, and out is actually z now. Okay, it's going to be your output value. This builds context to lead me into the main point, which is called composite functions. Composite functions, or composition functions, or I believe it's just composite functions. Actually, composite. Sorry, I'm writing this on my main notes here. Okay, so now you might get something that looks like this: G circle F or F circle G, and we're going to get back to this, but let's focus on G circle F. Another way of saying this is G of F of X. You might have seen that before, but what does that actually mean? Well, if you go back, G of X is G of whatever my input is, and my input value was X, means that whatever my input value was is being added to 2 with the square root, and you take the square root of that. Well, this is no longer the g of x. This is technically the g of f of x. What the heck is f of x? Oh, well, f of x is sort of another output value or mechanism. It's x squared minus 3. So this whole thing now is the new input. So f of x, the new input, and then fx is x squared minus 3. We put that into this position. So here, g of f of x is now going to be almost the same thing as what you see here, x plus 2, but now in place of x, you're going to put in the whole equation, x squared minus 3, that's plus 2. So again, g of whatever the input is just whatever the input is plus 2, take the square root. If you go back up here, or you go back in here, the whole input is x squared minus 3, basically. Then you add 2 to it, and you take the square root. It's nothing different from what you've done before with the g of whatever. Except now the g, you've never seen it like this, written like this, but this is not inaccurate. F of x is x squared minus 3, because we've established that f of x in our context is x squared minus 3. Okay? And then you can simplify this. So x squared, you have minus 3 plus 2. Minus 3 and plus 2 can be kind of combined because they're like terms in the sense that they're whole numbers. X squared minus 3 plus 2 is going to be minus 1. And I think a lot of you guys in math might see that that can expand to two binomials, x plus 1 and x minus 1. If you don't believe me, okay, and this is actually very useful, you're going to see why. Oh, I'm sorry. Lost of train of thought. What was I going to say? You're going to see this when we graph why this is important. And in case you don't understand what just happened, I expanded this into two binomials. And if you multiply everything out, like the x towards everything in this parentheses, and this 1 to everything in this parentheses as well, and then you add everything together, you only end up with x squared minus 1. Okay. Now it's going to ask you. Oh, and before I go on, let's look at what just happened with the same diagrams that we drew up here and here. I first started with an input value of x, and I put it through the f mechanism, or the f function, okay, which is, in this case, x squared minus 3, and I got some output value. The thing is, you don't see y anywhere. So, but again, it's synonymous. I told you, it's almost the same thing as, or almost, pretty much, almost 100% the same thing, but it's not. The output value is synonymous with f of x. And it's like taking f of x and putting it through g to get the new output. And I don't even know what letter I should put there. And whatever the new output is the g of f of x. Okay? So if you, again, I put x through a function, I got an output value of y, but you don't see any notation of y in here. And that's perfectly fine. Okay? That's perfectly fine, because another way of saying that is the output was f of x, and then you take this f of x and you put it through g, and now the new output is the g of f of x, which is what we just figured out. So the problem is, what's going to be the domain? What's going to be the range? That I don't know. So in this case, it's really the fastest answer to this, or the fastest way to figure this out, is just to graph it. So let's go ahead and graph it here. Let me see. So I went to desmos.com. You just type in desmos.com. Okay. Yeah, I'll just leave this here for now. Let me show you what it looks like when you get to Desmos. Start graphing. So you can use a TI-83, but I'm going to just choose to do this. Uh-oh. Battery's kind of running low, guys. Okay. And then I'm going to put in my original. So I like to put it in originally the way it was before I simplified it. So again, I put SKQRT, and it recognizes as a square root sign. And I'm going to put in, whoops, x squared minus 3. Again, before I simplified it, let's close that parentheses, plus 2, okay? And then now, it seems like all the range is actually, doesn't go below anything negative. So I like looking at the range because it looks like it goes from 0 to like positive infinity. And let's see, it includes 0 too. So that, does it? Yeah, I believe it does. Okay. Actually, it's hard to tell if that's a hole or not, but yeah, so that might be a hole. Okay. But I think that might be inclusive. I forgot how Desmos is, so I have to check that in just a second. As far as I can tell now, range is going to be, what is it? The range is going to be greater than, I think it's from 0 to, I think, positive infinity. Okay, so that's the range. And then, interestingly enough, all the x values are less than -1 and yet greater than 1. Nothing in between has a number. So we'll see why that is in just a second. So let's write that. How we would write that is x can be anything greater or less than -1. Well, let's see. Is it? Let's see. Oh, no. I think I got that wrong. I think x has to be less than or equal to -1. And x also has to be greater or equal to 1. That's the domain. It's not this. I was about to write this, and this is incorrect. This is not correct. Let me open, let's kind of zoom in on that again, okay? So just letting you know, the proper notation would be on the left-hand side here. You don't want to write this with a crossbar, but this is true. The domain pretty much can't be these numbers in between here and here, okay? So this is not the domain. This is the domain. Numbers have to be greater or less than or equal to -1. Again, numbers have to be less than -1. So everything to the left of -1 is less than or everything to the left on the x-axis to the left of -1 is less than -1. And that's true. There's graphable points at these x values. There are no graphable points between -1 and 1. Okay? Why is that? Give me 1 second. I got to put in my charger on my computer before it dies out. Phew, that was a close call, guys. Sorry about that. It's a weird pause, but it's an organic pause, okay? Now let's look at why it can't be numbers in between -1 and 1, okay? Let's test out a number that's at between -1 and 1. Mr. Wade likes to do numbers that are easy. Well, whatever number you can think of, I think the easiest number would just be to substitute a value in a 0, okay, which is perfectly in between -1 and 1, equally spaced between -1 and 1. Let's go back to, oops, this is a notepad that I use for another class, okay? So the g of f of x is equal to, what was it? Originally, it's x squared minus 3 plus 2. I'm going to show you in a little bit why I prefer to use like the unedited version before I started making some adjustments to it. Actually, let's just do the simplified version. Why not too? Of this x plus 1 and x minus 1. Okay. If I put in 0, look what happens. 0 squared. So this is the g of f of 0. 0 squared minus 3 plus 2. Then you get 0 minus 3, which is minus 3 plus 2. And then finally, you get -3 plus 2. That's -1. The square root of -1 is not a real. I mean, if you have to know, it is plus or minus I, but that's an imaginary number. Let's try that again here. 0 plus 1 times 0 minus 1 would equal the square root of 1 times -1 again, which is -1. That does not give me a real number, or the square root of that. That gives me plus or minus I. Again, why does that not work? Because on this graphing system, we cannot represent imaginary numbers. You can only represent real numbers. Okay? So there you have it. That's how you get the domain for these things. I would recommend graphing it. Might have a tutorial video on how to do that with the TI-83 so you guys can remember how to use that. So maybe I should start doing that as a habit if I don't have a TI-83 on me. Okay, so in the future, we'll start graphing with the TI-83 as well. All right, gang, I'm going to go ahead and stop there, and then I'm going to go on to something that I did not bring up, which is the f of g in part 2. Okay, thank you guys very much. Join me in part 2 for that.